Hello and welcome to video 4.3 on factoring, third term factoring to be precise. This is in our unit 4 on polynomials. The pizzazz pages that go with this are 88 through 90. Hopefully by this time you've added your name and date to this note sheet, and let's get started with some vocabulary. The first vocabulary word that we're working with is factoring, which is the process of breaking a polynomial. Again, the process of breaking a polynomial expression into its component parts. So the process of breaking a polynomial expression into its component parts. Now this is the opposite operation. The opposite operation to simplification. And the next vocabulary word we're going to use is third term factoring, the actual subtitle to this section. And when we take a look at third term factoring, this is a technique for factoring whose leading coefficient is 1. So this technique used for factoring we use for trinomials, and remember tri meaning 3. So there are 3 terms in this polynomial. And the coefficient is 1, and we're important about the first coefficient, so that leading coefficient. Coefficient is the number part, and an example of a trinomial whose leading coefficient is 1 is x squared minus 5x plus 6. And we're really taking a look at that first term, so that x squared, where there's an invisible 1 in front of it. So taking a look, we're going to go and move to those key concepts. So key concepts, we're talking about a method for applying third term factoring. And the first step to this method, again the method is the third term factoring method, is to arrange the trinomial in descending order. And a reminder from Unit 2, descending order is when the terms with the highest power are first, and then down from there. So we have an example that we were given previously when we talked about up in the vocabulary, which was x squared minus 5x plus 6. Now, if I take a look at this, I'm looking to see if this is in descending order. So that term has an x squared, that's an x to an invisible power of 1, and there's no x there. So in fact, we are going in descending order. That's good news. So let's do number 2. Step 2 asks us to list factor pairs of the third term coefficient. And those factor pairs are things that multiply to that third term coefficient. So we're looking at that 6. Oops, let's hold on. We're a little fast here. So I want to find factors, things that multiply to 6. So 1 times 6 and negative 1 times negative 6. 2 times 3 and negative 2 times negative 3. Okay, so I've listed all of those that multiply, all the numbers, the integer numbers that multiply to 6. The next step is to circle which add, so which pairs add to the second coefficient. And I'm looking at some mental math here. So I want to find out which pairs add. Again, we're adding them to finish off and get this -5. That's the second term coefficient. So in my mental math, if I add 1 plus 6, I'll get 7. -1 plus -6, I'll get -7. 2 and 3 together give me 5, and -2 plus -3 give me -5. And that's the one in which we want to work with. So I go ahead and I circle that. From there, I'm going to work on the next step, which is to replace the second term with the factor pair. So in doing that, I replace the -5x, I replace this guy with the term -2x and -3x. Essentially, we're doing the opposite operation of simplifying. And we've talked about FOIL, and we'll use FOIL here as a check. And that's why we do this replacement. So if I take these pieces, and I'm going to double check that in fact -2 added to -3 does in fact give me -5. And my next step for step 5 is to write the factored form. So I'm going to have a pair of binomials, so here's a binomial and there's a binomial, that are multiplied together. So my factored form, I'm going to take a look. And when I talked about doing that reverse for FOIL, this here is that concept of the first term, the outside term, the inside terms multiplied together, and those last terms multiplied together. So if I look at that, I'm going to make a binomial times another binomial. And I'm going to put, let me back up here. I'm going to put x in both the first and the second position here. So this indicates the first terms multiplied. X times x is going to give me that x squared. So that's that front terms, or those first terms. Next, I'm going to take a look at this -2x. And if I multiply x times the outside, so x times something, I need this to be a -2. And then this being a -3, if I was to multiply these inside terms, I would get -3x, so that's a good check. And the last terms, so -3 times -2, I already organized that here, in fact is +6. So step 6 is to use the FOIL method to check your answer. And so in fact, as I'm going through, I am doing that, but you may notice I want to do it yet again. So the check for FOIL, and that goes so quickly. Let's back up here. The check for FOIL is x times x, those front terms. In fact, that's true. X times -2, yep. The inside terms, yep. And those last terms. Again, this is FOIL for front, outside, inside, and last. Now I do want to have us be aware of something. So on this method, please be aware that if it doesn't check out, there's two options. Either we made a mistake, which is totally possible, or this is a prime polynomial. Prime polynomials mean that it's not factorable. There's a lot of information I just handed out to you. We've got our vocabulary, method, and our first example. Again, this whole section in here is mental math and not something that we necessarily need to write down. This section is expected to be seen on your showing the work. So please write down all the factored pairs. All right, let's take a look at another example. So flipping the page over, we're going to title this 4.3 third term factoring. And we don't have any new vocabulary for the back or key concepts. We gave you a lot in the front. So let's go ahead and flip to our first example in the back, which is example number 2 in total. So let's look at this as n squared minus 8n plus 12. Now, my first plan here is to arrange the trinomial. And in fact, I take a look and this is n squared and then n and then no variable. So in fact, it is arranged in descending order. Step 2 is to to list the factor pairs of that third term coefficient. So as I do that, my factored pairs of 12 are 1 and 12, negative 1 and 12. Let's back up this, it's going super fast. Makes more sense for us to slow down. So positive 1 and positive 12 multiplied together. Negative 1 and negative 12 multiplied together. 2 and 6, as well as negative 2 and negative 6 multiplied together. We can use a positive 3 times a positive 4 and a negative 3 times a negative 4. At this point, I want to check to see if any of these add to give me that negative 8. And here we can use some mental math if we choose. I can pretty quickly recognize that 1 plus 12 is not going to get me there. So that's not going to work out. Negative 1 times negative 12 also will not add to negative 8. And positive 2 plus 6 will not get me there, but we're much closer. Okay? We're pretty close here. So taking a look, then maybe it works with negative 2 and negative 6 added together. In fact, that is the case. So I'm going to replace the second term of negative 8n, and I'm going to break it apart because that's what factoring is about, is breaking it apart into its components. So I'm going to write this. I circled the components that worked of negative 2 and negative 6. I'm going to write down n squared minus 2n minus 6n plus 12. Now when I take a look at this, in fact, if I was to add 2n, this negative 2n, and this negative 6, I would come back to the negative 8n. So that's in good shape, and that really helps me out to clarify that I've broken this up. Now from here we're doing the reverse FOIL bit, so we're going to have two binomials. And I'm going to have n times n as my first pieces. Then in order to get the outside terms, I'm going to have to place a negative 2 in the last position. So for those outside terms, I'm going to have n and negative 2. For the inside terms, I need them to multiply to negative 6n. So I'm going to need to place a negative 6 in the box. And I'm going to check if negative 6 for those last terms in fact multiplies negative 6 times negative 2 to a positive 12. That's reversing the whole FOIL method that we're working with. Now perhaps you've taken a look and noticed that the negative 6 and the negative 2 that are placed in the binomials in fact are the factor pairs that we recognized. So that's also another way to organize and think about this. If we circled the factor pairs, those are what should be being placed inside the binomial. Excellent. So at this time we're going to check our work. We've written our factored form. We're going to check it using the FOIL method, so I'm going to multiply the first numbers, the outside numbers, the inside numbers, and the last numbers. I box in my answer of n minus 6 times the binomial n minus 2. Now here maybe let's practice the factor tree. So let's get some extra practice. With making a factor tree. And we're going to start with negative 10. Now when I talk about practice with the factor tree, I'm just organizing this idea right here, this factor tree right here, of working out how to do that. Now negative 10 I can multiply by negative 1 and positive 1, or 1 and negative 10. Now I'm not sure I said that correctly, so I'm going to repeat myself. It's that multiplication of negative 1 times 10, or positive 1 times negative 10. I also could multiply by negative 2 times 5, or 2 times negative 5. That would be the factor tree of negative 10. Now let's take a look at a factor tree of 24. Whoops. I would have 1 times 24, or I could have both negatives, negative 1 times negative 24. I could also work with 2 and 12, or negative 2 and negative 12. Similarly, 3 and 8 work, or negative 3 times negative 8. 4 and 6, or negative 4 times negative 6. Now let's do one more together of 48, and I'm going to do negative 48 just to work on those negative skills. So I would work on negative 1 times 48, or 1 times negative 48. Two times 24, or negative 2 times 24. Negative 3 times 18, or 3 times negative 18. 4 times 12, or one of them has to be positive or negative. So negative 4 times positive 12, or positive 4 times negative 12. I also can do 6, so negative 6 times 8, or 6 times negative 8. So it's important to then take a look at, rather than trying to write out all of these, perhaps asking yourself this question. The question is, how many negatives should I have? Should there be 2 negatives or no negatives? Is it possible to have only 1 negative? If there's only 1 negative, should it be on the larger number, or should it be associated with the smaller number? Now, this question right here is a lifesaver. You don't necessarily have to write out all of those if you can identify that, hey, maybe I only need the larger number to be negative. Then I can only make one set, and I don't have to go through the pairings in such an order. Let's take a look at a couple more examples. We are running long on time, so I recognize that. Taking a look, if I had the polynomial y squared plus 4y minus 21, again, this is a trinomial because there are 3 terms. They are in descending order. And I take a look at this and I need to make a factor tree for negative 21. That's my third term coefficient. And negative 21 can happen if I make it, first I'm going to ignore the negative. I'm going to say 1 times 21 and 3 times 7. Then I'm going to ask myself, how many negatives should I have? If I'm multiplying to get a negative, I only need 1. And I can recognize if I need to add to a positive number, then my negative needs to be the smaller number. So I'm going to place the negative in front of the 1 and a negative in front of the 3. And I've really shortened up my factor tree now. The next step is to indicate which factor is going to add to that positive 4. And in fact, it's going to be the negative 3 plus the positive 7. So I want to go ahead and circle the factor pair that works. And I also want to rewrite it, as you notice, in this factored form. So I'm breaking it out. So that's happening here and here. I'm making circles when I want to be making lines. So those two add to a positive 4y. So it's breaking apart that piece. And this is going to help us because we're going to make our binomials now. So I'm going to make my binomials and place a y in both the first places. And recognize that I have this concept down here of a negative 3 and a positive 7. So I'm going to write negative 3 and positive 7 inside there. And when I take a look at this FOIL method to check myself, I do multiply the inside terms, the front terms, the inside terms, the outside terms, and the last terms. And in fact, that works for me. I have a couple more examples to work with. So please flip the page to the extra examples sheet. Again, we're working on continuing the 4.3 third term factoring. This is x squared minus 3x minus 10 as this polynomial. It is in descending order, and I'm going to find the factor pairs of negative 10. That means I'm working with 1 and 10, and negative and 2 and 5. Since I want them to add to a negative number, the larger number needs to be negative, so I make it a negative 10 and a negative 5. Then I break the negative 3 apart. So if I put these together, I'm going to write x squared plus 2x minus 5x minus 10. When I do that, I'm going to indicate the FOIL method and place these into my binomials by having them say x and make one a plus 2 and one a negative 5. Checking that with the FOIL method, in fact it does check out. For our first trinomial is number 5, it's x squared plus 5x plus 6. So please indicate the factored pairs of 6 and find those that add to 5. The The next step is number 6, which I've done partially out for you, for w squared minus 5w plus 24. When we take a look at this factored tree, we need to have two negatives multiplied together to multiply to a positive, but add to a negative. In 6, you'll notice that there's actually not a single pair which add to a negative 5. That tells me that this is a prime polynomial, which means it's not factorable. And example number 7 is the last try on your own example, which is x squared minus 7x minus 18. Please come prepared with this note sheet completed and an attempt on these try on your own problems. Thank you for your time. We'll see you in class.